Well, you've probably already recognized that we're doing this chapter just a little bit out of order. I think it will be easier for you to understand some of the topics that they put in the earlier part of the chapter if you can understand states of matter first. Now, states of matter are probably something that you may have already talked about in an earlier science class. But today when we talk about states of matter, we're going to be looking at the particles, the atoms, the molecules that make up this matter that we talked so much about in the first video. We're going to be talking about the characteristics of these particles within these different states of matter. Now, what is true, as far as we are aware, again, so much of this is happening on a submicroscopic level, and we can't begin to see atoms and molecules, and even with the most powerful microscopes. We can't get a good, clear picture of an atom. But from the understanding that we have, we know that these molecules attract one another. And so what state of matter something is in depends on two things. It depends, first of all, on the attractive forces between the particles. Sometimes they're going to attract each other really strongly. Sometimes they're going to attract each other very weakly. You can compare that in your mind to when we were talking about magnetism and how you know that magnets some can attract each other very, very strongly, or sometimes you may have a really, really weak magnet. Now, this is not a magnetic force, but there are forces that attract atoms and molecules to each other. And so the more strongly they're attracted to each other, the closer that those particles are going to be together. The other thing that's going to affect what state of matter something is in is the amount of kinetic energy of particles. And we've talked a lot about kinetic energy. We've talked about energy of motion, and we know that the faster something moves, the more kinetic energy it has. And we've already talked about the fact that particles are moving. So if they're moving, therefore they must have kinetic energy. So let's compare solids, liquids, and gases to one another as far as what their particles are doing down on the atomic or molecular level, and see if we can get some understanding as to what the differences is between these three states. Now, your book does talk about the fact that there is a fourth state of matter called plasma. And while that is true, in this class I don't intend to spend much time on it. And the reason is because the things that are in the state of matter called plasma are going to be things like the sun and stars, and they're not things that we have everyday experience with, beyond the fact that the sun warms us up. But as far as the things that we're daily handling and moving around and eating or drinking or playing with or doing whatever our activities are, we're not going to be having any type of direct contact with something that's in the state of matter of plasma. And so that's why our focus is going to be strictly on solids, liquids, and gases, which we have experience with every single day of our lives. So let's start with a solid. These circles represent atoms or molecules, and in a solid, they are very, very tightly packed together. And so the particle spacing in a solid is very, very close together. Now, your book also talks about the fact that in some solids there is a nice crystal arrangement where everything is super, super organized. And then there are other solids where it's kind of like the molecules are just kind of mushed all together and there's not really a whole lot of structure. That's something that we're not going to spend a lot of time on, but I wanted you to be aware of it. If you've ever grown crystals, I know a lot of elementary science programs will have projects, where you're growing crystals. And so you can see how those atoms and molecules stack themselves together in very neat configurations in order to make the structures and the rocks and the minerals that they make up. So in a solid, your atoms and molecules are very, very close together. The particle motion, because we said that all particles are going to have some sort of kinetic energy. And so the particle motion in a solid, the particles are simply vibrating back and forth. So they might be vibrating back and forth this way. They might be vibrating back and forth up and down. They might be kind of going this way. It's all very random, but it's all vibrating, and so the molecules are not moving apart from one another. They're just vibrating back and forth. Now, with a solid, again, if you think about anything solid that you're aware of, whether it's a marker, whether it's a dry erase board, whether it's a cup of some sort, we are aware that the volume is not going to change in a solid, and the shape of that solid is not going to change. And so both the volume and the shape of a solid are going to be fixed. And you're also aware that if you have a solid, like the marker, I can't take the marker and squish it or push it or make it any tighter together than it already is. So really, there is no compressibility within that of a solid. The word fluid simply means, does something flow? Can I pour it? Can I make it run? And with a solid, the answer again is going to be no, it doesn't have any fluid properties. If I have a big box of wooden blocks and I take them and I dump them all out on the floor, I'm dumping them. They didn't flow, they just dumped. There was no grace, no flowing motion to that at all. They just all poured out. So now let's compare that to a liquid. With a liquid, water obviously is a liquid at room temperature. And so the molecules are still close together, but they're not quite as tightly packed together as they are in a solid. So they're close, but they're not as close together as that of a solid. And the particle motion in a liquid, they are going to be able to slide and to move past each other in a liquid. And again, we can see that happening if you take a glass of water and you put a drop of food coloring in it. The particles obviously are going to be moving all over the glass because the food coloring eventually will fill the glass and make the entire glass a different color, a glass of water a different color. So all of these particles are sliding past each other. The volume, I can't take a glass of water and make it fit in a smaller container. If the glass is full, it takes that much space to hold the water, and I can't squish it down. I can't make it take any less space than it would otherwise take. So in a liquid, the volume is going to be fixed, but I can take that same liquid and I can put it in a different shape container. I can put it in a bowl, I can put it in a glass, I can put it in a bottle, and I have the same volume, but the shape of the liquid is not fixed. It can change, even though the amount that's there cannot. And like I said, it's you can't take a bottle of water and squish it down to make it take up less space. So a liquid is also not compressible, but it does flow. Can I pour a liquid? Absolutely. So a liquid is considered a fluid because it will pour while a solid does not. All right, third state of matter is a gas. And with a gas, the particles are really, really, really far apart. They are not close together at all. In fact, they probably are pretty rarely going to collide with each other, going to run into each other at all because they are so far apart. And the amount of kinetic energy that these particles have, these are just vibrating. These are sliding past each other, but these guys are kind of just flipping all over the place around each other. I think that one definition I heard was you could think of it like a hyperactive fly. They're kind of just going all over the place. And so the kinetic energy of the particles of a gas is very, very high. It's going to be much higher than a liquid, and the kinetic energy of the particles of a liquid are going to be higher than that of a solid. Particle motion, these guys are operating at a very high speed. Okay, not just sliding past each other, but zipping by faster than race cars. With the volume and the shape, I could blow air into a long balloon. I could blow it into a round balloon. If there were such a thing as a square balloon, I could do that too. And so the volume, the shape is what I was talking about there. The shape of a gas is not fixed because it's going to take the shape of whatever container you put it in. Just like water or a liquid is going to take the shape of whatever container you put it in. But with a gas, because there is so much space in between these molecules, I can take that and I can compress it down into a smaller space. So with a gas, the volume of it is not fixed either. In fact, you've probably heard of air compressors. We have an air compressor out in our barn that we use to inflate the tires on our bicycles or the tires on our cars, or to use for certain kinds of power tools. And so what that air compressor does is it takes the molecules of air and it pushes them together in a much tighter space and puts them under a lot of pressure. So is a gas compressible? Absolutely it is. You can compress it and change that volume, whereas with a solid and a liquid, you can't change the volume because they are not compressible. So the volume and the compressibility are directly related to each other. Finally, is it a fluid? This one's a little harder to see, but yes, these particles will flow and gases are considered fluids. If you've ever seen a demonstration where people have liquid nitrogen and they will take the container of liquid nitrogen and they actually will take it and they will pour it out on something, you can see there that liquid nitrogen actually flows. Of course, that's liquid nitrogen, and then what happens with a gas is you can see that it turns into a gas as it warms up and comes into contact with the air. But you can see again that's because it's so cold, those particles are condensing. You can actually see them pouring as well. Okay, so you can see the differences here between a solid, a liquid, and a gas as far as particle spacing, as far as the motion of the different particles, the volume, the shape, the compressibility, whether they're considered fluids or not. And again, the thing to remember is that all of this depends on how much the forces between the particles are attracting one another. So with a solid, they're attracting each other a great deal, whereas the particles of a gas are not attracting each other nearly as strongly as the ones of a solid. In the amount of kinetic energy of the particles, a gas is going to have a lot of kinetic energy in its particles, and a solid will have very little kinetic energy in comparison. Okay, so that's states of matter. One other note I wanted to make, in the experiment that you did, you saw that the particles are constantly moving, and hopefully one thing that you also notice is that the higher the temperature, the higher the kinetic energy. And so if you take matter and warm it up, one thing that you, again, should be very obvious is that as something gets warmer, it has more heat energy and therefore it has more kinetic energy with it as well.